Greetings, A-level chemists. Welcome to an explainer video where we're going to look at precipitation reactions of transition metal complexes with sodium hydroxide solution. So we'll talk about the theory first, then we'll answer the questions. So, sodium hydroxide is a strong base, and people often think that when we're reacting TM complexes with sodium hydroxide, these are ligand substitution reactions, but they are not. So this is a strong base. Okay, so there is my strong base. And what happens is, my strong base comes along, and the definition of a strong base is that it accepts H+. And while we're there, let's have a look at the definition of an acid. An acid is defined as an H+ donor. Okay, well, my hydroxide ion comes along, and here is my hexaquicopper 2+ solution. So this is CuH2O6 2+, and it's aqueous, dissolved in water. Okay, I'm going to ignore the 2+ charge, but remember it is there in the complex. Okay, so my OH- ion comes along, and what happens is it's seeking protons. So there it is. So it seeks a proton, and a bond is formed. So we get one water molecule being formed, okay? Because what happens is we get a bond forming here. So my complex ion is behaving like an acid, and my OH- is acting like a strong base. So we get an acid-base reaction, and look what happens. We get a water molecule forming, and we're left with OH attached, and initially we had a water ligand there, okay? So we get one molecule of water, and look how our complex has changed. So our complex has changed, okay? So it's no longer CuH2O6. What is it? Let's think about this. It's now CuH2O 1, 2, 3, 4, 5. So we're sort of going to show this in real time. And we've got one OH there. And now it has a +1 charge because hydroxide is 1-. Okay, so copper is 2+, OH is -1, 2 take away 1 is +1 so far. But what can happen is we can get another deprotonation. So another hydroxide ion can deprotonate in an acid-base reaction as such. And if we get another deprotonation, look at what we get. We're going to get a water molecule forming. So my complex ion is behaving like an acid, and my base, my OH- is behaving like a base. So we get another water molecule forming. So let's show that and rub these all out. Okay, so I have formed 2 lots of water, and look at what I formed now. In my complex ion, I've got 2 OHs and now 4 water molecules. So I'm going to change this. So this becomes H2O 4 OH2, and we don't have a charge on this anymore. So this is actually neutral, and it is a solid, and this is actually a pale blue precipitate, and it's a gelatinous solid. So if we're going to write a chemical equation for this, if we show it the proper way, we've got CuH2O6 2+ aqueous, and I had 2 hydroxide ions. What we get is 2 deprotonations. So this is my acid, and this is my base, and I am left with Cu OH2 H2O4 neutral, and this is a solid, and 2 water molecules are formed. And this is a pale blue color, this sort of cyan color, and it's this gelatinous solid that we form. Okay, so that's one reaction. what is the reaction with chromium if we're using sodium hydroxide? By the way, if we use ammonia, we'd get the same thing. We get 2 deprotonations, but instead of forming H2O, we form 2 lots ammonium ions, okay? In the copper 2+ case. In the chromium, in the hexa aqua chromium 3+ ion, we get 3 deprotonations. And if we get 3 deprotonations, this is what we're going to form. Chromium hydroxide, H2O3, solid, plus 3 H2O, liquid. And this is a dark grey-green precipitate. So dark grey to green precipitate. PPT for precipitate. I'll just put green, but the color is subjective. It's hard to really tell. And there you go. So these are acid-base reactions, not ligand substitution reactions. Okay, thanks for watching. Ta-ta.